안녕하세요. 마이오케어 대표 김일영입니다. 오늘은 아미노산 단백질의 최고권위자이신 로볼프 교수님을 모시고 건강한 근육에 대한 필수아미노산의 역할에 대해 알아보도록 하겠습니다. It is important to know that gains in muscle mass is effectively achieved when the precursors, that is, amino acids, are sufficiently provided. Could you tell us how provision of amino acid in the form of protein or amino acid supplement increases the efficacy of resistant exercise for building up muscles?
I think we have to have a little background in how muscle protein is produced. Protein is a long string of amino acids that are linked together in a very specific order and a specific amount. And the way this protein is produced is one amino acid is hooked on to the next, to the next, to the next, and so on. And there is a specific code dictated by the RNA in the cell that for every single protein, there's a unique pattern of the sequence in which these essential amino acids, as well as non-essential amino acids, are linked together. So as you proceed in the production of a protein, which is initiated by the exercise, and so now you've started what we call translating the RNA into a true protein, one amino acid after another is linked together, as long as the amino acid is available. That will always be the case with a non-essential amino acid, because if the next amino acid up in the line to be linked together is a non-essential amino acid, if there's any kind of shortage of that amino acid, more can be produced. But in the case of the essential amino acid, if there is a shortage of any of the essential amino acids, when the next one in the line to be linked together is a missing essential amino acid or a low quantity essential amino acid, the translation of the protein will stop and a complete protein will not be produced. So therefore, we would call that amino acid the limiting amino acid. And there are 9 essential amino acids, and each one could potentially be a limiting amino acid, depending on the specific profile of the amino acids that are being produced, but are being linked together to produce an intact protein. In the case of skeletal muscle, we have a very good knowledge of what amino acid proportions are needed so that there's no one specific amino acid that is the limiting amino acid, but rather all of the essential amino acids are available roughly in proportion to their prevalence in the production of new muscle protein.
Thank you for the great answers. People typically consume high-quality proteins such as chicken breast, beef, eggs, and so on to build up their muscles. What does it mean by high-quality proteins? How does the consumption of high-quality protein versus low-quality proteins stimulate more muscle building? What are the main factors in the protein that leads to muscle protein synthesis?
Protein intake in the diet is very important and essential to maintenance of adequate muscle mass and strength and function. There are a variety of factors that determine the quality of a protein. When the protein is eaten, it has to be digested and the amino acids absorbed to have any effect. And the digestibility of dietary proteins can vary much more than most people appreciate. Some of the animal proteins that are quite popular, like whey protein or beef protein, milk proteins, over 90% of what is eaten is actually eventually absorbed. But in other sorts of protein, for example, wheat protein, less than 50% of the protein that is ingested is actually digested and amino acids absorbed. So the digestibility is one factor. This is not an issue with free amino acids that are 100% absorbed. The second aspect of the quality determination of dietary protein is the amount of essential amino acids relative to the non-essential amino acids in the protein. So that the building blocks to the protein are the amino acids. The more essential amino acids that are in the dietary protein, the higher the quality. And the reason that this is such a universally accepted principle is the fact that only the essential amino acids are actually required for the stimulation of protein synthesis. So if the individual eats beef protein, and then and the beef protein stimulates a certain amount of muscle protein production. If you then take all the amino acids in the beef protein and eliminate all of the non-essential amino acids, and then eat just the essential amino acid component of the beef, you'll get the same stimulation of protein synthesis, meaning that only the essential amino acid component is important in terms of the dietary effectiveness of the protein and stimulating the production of new protein in the body. So for that reason, the WHO, the Food and Agricultural Organization of the United Nations, all recognize that the quality of the protein is largely dictated by the amount and the profile of the essential amino acid component of the dietary protein.
Okay, thank you for your answers. High intake of protein, high quality protein, or essential amino acid negatively affect kidney function?
The excess amino acids in the body are metabolized, and the nitrogen goes to produce urea, which is then secreted by the kidney into the urine and out of the body. There has always been a concern that eating too much dietary protein would cause an excess intake of the amino acids that go to the production of urea, putting an additional burden on the kidney and ultimately causing kidney problems. It turns out that this is not true. If someone has kidney failure, then they are less capable of secreting the urine. So that in that case, a high protein diet is a problem. But in the case of a normal individual, even an elderly individual who has somewhat compromised kidney function, the intake of dietary protein has no impact on renal function at all. That being said, it's important to understand that the principal issue with protein intake relative to the kidney is the amount of non-essential amino acids. I had said earlier that the quality of protein is largely determined by the amount of the essential amino acids relative to the non-essential amino acids, so that with a high quality protein, you have much more essential amino acids and much fewer non-essential amino acids. The non-essential amino acids are the ones that produce the urea that the kidney has to secrete from the body. So therefore, if you do have any sort of renal deficiency, eating a high quality protein that has a lower amount of the non-essential amino acids will benefit the body by the fact that there will be less burden on the kidney to secrete urea. Taking it one step farther, if we have only pure essential amino acids, the non-essential amino acids that would normally be going to the production of urea are instead reincorporated back into protein, and we actually see a decrease in the amount of urea produced and the burden on the kidney, even despite the fact that you're eating a higher amount of dietary protein. The reason that this works this way is because the essential amino acids are, for the most part, not producing the urea in the body.
Thanks. So even in the person who has kidney dysfunctions, they still need the essential amino acid and amino acids. So in that case, I think the consumption of essential amino acid reduce the burden on the kidneys potentially. Correct?
Yes, that's right. I think that that's an important aspect, because if the kidney failure actually causes a rapid loss of muscle mass, so the individuals with kidney failure or kidney dysfunction have a very strong requirement for amino acids to make muscle protein. However, if they have liver failure, the intake of non-essential amino acids that come with dietary protein, particularly low quality dietary protein, will be problematic. And in this case, the optimal approach is to have predominantly a high essential amino acid intake relative to the non-essential amino acids, either through eating largely high quality proteins, as well as taking essential amino acid supplements that do not have any burden on the kidney.
The next question is that protein is composed of 9 essential amino acids and 11 non-essential amino acids. Could you tell us the difference between these two categories of amino acids regarding muscle gains?
The dietary protein does not necessarily have all of the 21 amino acids that are in dietary protein, but a complete dietary protein contains all of them. The 9 essential amino acids cannot be produced in the body, and there is a dietary requirement to eat a certain amount of each of those 9 essential amino acids every day to maintain body health, particularly related to skeletal muscle. The non-essential amino acids are called that because deletion of any of them from the diet does not have any impact on growth, development, or muscle mass or strength. So that the non-essential amino acids are produced in the body, but nonetheless, they comprise about 50% or more of most dietary protein. So you wouldn't say that they're not needed at all because they play some role, but by and large, the necessity of non-essential amino acids is far less than the essential amino acids in terms of a healthy diet.
Okay, if essential amino acids are the only components of proteins that induce muscle protein synthesis, it seems that essential amino acid supplement works better even than high quality protein for a given amount of calorie intake. In other words, is consumption of essential amino acid supplement better than consumption of protein supplement for muscle building? How does it work better in muscle building when consuming essential amino acid compared to protein intake?
Well, I want to first clarify that my answer will address dietary supplements, and that the primary diet should be comprised of high quality protein as a significant component, and eating a significant amount of high quality protein is an essential aspect of the diet. As far as the actual supplementation to particularly enhance skeletal muscle, the free essential amino acid supplement will be more efficient in several respects than even the highest quality of dietary protein. For one thing, the digestibility is 100%. The free amino acid supplement is absorbed without any digestive process, so that the blood levels of the essential amino acids rise very rapidly into higher values than the amino acids that are contained in dietary protein. And furthermore, not all the amino acids in the dietary protein are absorbed. The digestion is not completely 100% for any known dietary protein. The second aspect that is important is that even the highest quality dietary protein contains at least 50% of non-essential amino acids, which as dietary supplement is definitely not necessary. They're redundant to the amount of non-essential amino acids that you eat through your normal diet, so that without any other factor, about half of the highest quality dietary protein, such as whey protein, serves no real purpose in terms of amplifying the response of protein synthesis to resistance exercise. And the third point, which is equally important, I think, and less well recognized, is that the dietary protein has a fixed amount of each individual amino acid. We can't manipulate them, even if it's not ideally suited for the synthesis of any particular product in the body. We know in many respects what the optimal formulation is dependent on the specific group of proteins that we're trying to activate, and that's true for muscle protein in particular. We know exactly what the optimal ratio of the essential amino acids should be, and there is no dietary protein that has that optimal ratio of amino acids as the composition. But with a free amino acid mixture, we can comprise whatever ratio we want, so that when we have a formulation of essential amino acids to activate protein synthesis in skeletal muscle and aging through very detailed research, we have a very good idea of exactly what that profile should be to have the optimal response. And what experiments have shown is that when all of these factors are taken into account, the digestibility, the absence of any non-essential amino acids in the essential amino acid formulations, as well as the optimal formulation of the amino acids, that studies have shown the essential amino acids to be 3 to 4 times as effective as the same amount of dietary protein in stimulating muscle protein synthesis following a resistance exercise.
Thank you. If essential amino acids work better than protein, is it due to any single amino acid, for example, leucine, or groups of essential amino acids such as branched chain amino acid? Many people consume leucine or BCAAs, branched chain amino acids, for building their muscles. Does this work or not? If not work, why is it?
Leucine is a very important essential amino acid. It's important in the relation to skeletal muscle for 2 reasons. One, of all the essential amino acids, it's the highest percentage. In other words, there's more leucine per gram of skeletal muscle protein than any other essential amino acid in the protein. The second effect, which is maybe more important in some circumstances, is that leucine can actually serve as a regulator of metabolic processes, including the initiation of protein synthesis, so that a high amount of leucine can activate protein synthesis effectively. However, and so that leucine alone, though, has not been used effectively at all, because the problem with leucine alone is that it activates the process of the degradation, not only of leucine, but also of the other branched chain amino acids, valine and isoleucine, so that if you take leucine alone, you will get a deficiency in the isoleucine and valine. So conventionally, people have taken the so-called branched chain amino acid supplements much more than leucine alone, but that's all for the same purpose, and that's to initiate the process of protein synthesis. However, that the effect of activation of the protein synthesis by leucine is exactly the same as exercise alone, and that is that without the building blocks of new protein, the activation of the initiation serves no real purpose. So that when we look at all the literature taken together, there's no effect at all of a single amino acid of leucine or of the branched chain amino acids in stimulating new muscle protein synthesis. The problem being that the deficiency in the other essential amino acids limits the ultimate production of new proteins. So that leucine and the other branched chain amino acids are important components of any essential amino acid formulation, but by themselves have not proven effective at all in increasing muscle growth.
Okay, simply speaking, just don't consume leucine alone.
Yes, leucine alone has absolutely no proven value at all.
Why all 9 essential amino acids needed, and what will be the balanced essential amino acid that leads to optimal anabolic response? If there exists an optimal formula of essential amino acid, what would it be, and what are the basis for that formula?
The answer to that question is complicated because in a general sense, the optimal formulation depends on the specific proteins that are being produced. The reason proteins are distinct from each other is largely determined by the amount of each individual amino acid in that protein. So that with different proteins, they have different amounts of each of the essential and non-essential amino acids, so that for a formulation to be stimulating, for example, muscle protein synthesis, we wanted to target the profile of the amino acids in muscle protein. But on the other hand, if the protein that we're trying to produce is involved, such as ApoB100 involved in liver fat regulation, it's a completely different formulation of amino acids. So that in a general sense, it's a complicated question. But with regard to muscle, I think we have a very good handle on, a very good idea of what the ideal composition should be. There are two aspects that we want to always be thinking about in stimulation of muscle protein synthesis. One is the activation of the initiation or starting the engine up. And secondly, providing all of the necessary building blocks for the new protein that's produced. In the case of older individuals, for example, the ability to get the whole process started is very, very slow. And so that it benefits such a person to have a high proportion of leucine in the formulation, and then the remainder would be in balance in accord with what the relative proportions of the other essential amino acids are in the skeletal muscle. In a young, healthy person that's just finished an exercise bout, then it's a little different because the exercise has already provided this activation. So we don't need to have an extra amount of leucine to activate the process of initiation, but we can focus more on the components of the building blocks of the skeletal muscle protein. So the point is that the formulation of the essential amino acids, if we optimize it, is really targeting specific clinical condition as well as the presence or lack of exercise. And in that sense, the importance of the ability to make amino acids of different profiles is quite important.